Thanks. Right. Thank you for that characteristically warm welcome. It's a pleasure to be here once again. And I'd honestly had forgotten I was here in 2014. And it looks as though the tech is working as well. And so although, I was hearing earlier about how that might be an issue, actually, I'm really quite impressed. It seems to be a good setting. As the title says, what I'm going to do, both the next, say, 40, 45 minutes or so, and lots of time for discussion, is tell you about a problem which you may not have been aware existed, or you may have some knowledge about it, and the kind of things, the kind of ways in which we should be thinking about solving it. But what I really want to do most of all is explain why astronomers are concerned about this and, exactly what its wider ramifications are. I should say the Royal Astronomical Society, if you don't know what it is, it's the sort of UK body largely representing professional astronomers and also geophysicists for historical reasons. We have around 4,000 members. Everybody gets to call themselves a fellow, and they're based in the UK, and about a third of our membership is outside the UK, and that's sometimes people who've worked in the field here but have then moved overseas, or just people who don't have a large national society of their own, so they connect with us. Can I check everybody can hear me at the back all right, by the way? Good, okay. So I wasn't sure how much I should raise my voice, which is always a thing in these issues. So that's who we are, and for that reason, it's natural to me that we would take an interest in this, because part of our role is about being advocates for the science as well. We want to represent the community, most of all, though, the sciences of astronomy and also geophysics, the earth science we represent too. So that's why we took an interest in this. Now, first kind of proper slide. He said if it works, that's because I'm going the wrong way. Perhaps. Is that going to work? Always the way, isn't it? Overconfidence. But there we are. It'll work here, I think. Maybe it'll work here. There we go. Very worst. There we go. That at least did work. I think with this talk and any talk actually about the changing skies, and if you consider topics like light pollution more generally, it's really important to start with a relatively pristine sky. And there are plenty of these pictures online. You see them on websites, familiar to the astronomy community, like Astronomy Picture of the Day, but also if you look around, say, the images in Wiki Commons of the Milky Way, you will get beautiful, largely unsullied, pristine skies from all over the world. And, quite often, say, in the Western United States, but even to some extent in the UK as well. I was always impressed by the fact there would be a flurry of people going down to the south coast to take a picture of the Milky Way by Durdle Door, this recurring theme. So we are used to, I think, the assumption that even if where we live, it's not possible to see that kind of sky, that it's possible to go to it. Now, you might say that this has become ever more difficult, that it requires flights and so on, that we actually have to go to these places like the Western US or Chile or even the Antarctic if you want to be particularly ambitious. But within reason, it's an expectation, I think, that there are places on Earth where the sky looks as it has done throughout human history, and indeed long before that. And that's just one of those images I've grabbed. It's not even the Milky Way. It's just Starfield, Alexei Elfimov there. And that's the sort of image we like to imagine we can get if we go to a dark spot. So there are various challenges to this, obviously. And the most familiar one is light pollution on the ground, given the name artificial light at night. And you'll have other talks around that, caused by street lights, but also various other illuminations, floodlighting, and so on. And that is something we imagine we can escape. However, the beginning of the space age added in very, very slowly to begin with a different problem in this. In fact, I would say at the outset of the space age, nobody would really even have recognized it as a problem, although that changed quite quickly, as I'll explain. So I apologize if everybody in the room understands exactly how satellites work, but if you don't, this is a very simple demonstration and explanation. You can date it back probably even before that, but Newton had a famous cannonball thought experiment. And the idea was that if you took a cannon to a high mountain and you fired a projectile from that cannon, it would obviously go further. The faster it left, it would go further as the speed of the projectile increased, until at some point, in theory at least, it would go fast enough that even under the influence of gravity, it would curve around the Earth, it would be pulled back down to Earth. But the rate at which it was traveling would mean that it would never reach the Earth. It would just be pulled round by the Earth's gravity in a continuous motion. And that obviously doesn't work on the ground because we have an atmosphere. So if you fire something, air resistance eventually will slow it down and bring it to the ground. However, or it will destroy it if you fire it too fast. However, if you put it in space, then that problem is to a first order solved. I mean, I should say that the Earth's atmosphere extends a very long way into space, and there is an effect a very long way out. However, satellites are based on the premise that there isn't much atmosphere at the very least, that it may not be a perfect vacuum, but it's pretty good. And so if you put something into space, you send it round at a high enough speed, it will stay there. It will go round and round the Earth. And although it's continuously falling towards the Earth, its forward motion there is fast enough that it never gets there. Okay, until eventually, actually, most. Oh, I'll take questions at the end, but well, essentially, if you fire it fast enough, if you fire it very fast, it leaves the Earth altogether. But if you fire it at the right speed in the right direction, you can put it into orbit. And then once it's there, it isn't losing energy. Essentially, it's being dragged around like that. To a first order, I should say that if the atmosphere does extend out there, eventually it will come down, unless it's very, very high up. But then, that time scale varies. So since the beginning of the space age, we've got used to putting things into orbit. And, that's been the case since, this stuff that's going to work, maybe my clicker will work now, since 1957, although the idea was in place long before that. So it started famously with Sputnik 1, a full 12 years before I was born. There's never been a time when things weren't in space. Ironically, that's a NASA image of the flight replica there, because Sputnik 1 itself is not around. Launched by the USSR, the Soviet Union. And then the Americans followed very quickly with Explorer 1, there in the middle, which did things like discover the radiation belts around the Earth. And then the first UK one was this one, Ariel 1, launched in 1962, a communications satellite. And that actually set the kind of framework for the use of space thereafter, because you tend to think of space, at least people like me do, perhaps, we think of space as being a place for scientific discovery. Of course, it's rather more utilitarian than that. And many, many aspects of our everyday life don't necessarily depend on it entirely, but it's certainly integrated itself into modern society. So there we go, that's working nicely now. So some of the things satellites do, well, I would be the last person to argue we should simply switch all these things off. They're far too important. Communications is the obvious one. The first examples of, say, transatlantic television broadcasts through satellites, for example, although we use fibers and so on the ocean to do that too now. But it's still important. Everything, though, including weather. I mean, let's face it, we wouldn't have been anything like as aware of the storm that we had a couple of days ago if we didn't have weather satellites monitoring the Earth. Incredibly useful for that, particularly if you're out in remote ocean sites. It would be much harder to see those storm systems and much harder to see them as a whole. Earth observation in general. So actually seeing that, the Earth as a planet, understanding the way in which it's changing. Geophysics too, understanding the Earth's magnetic field, looking at seismic shifts and so on. You can do that from space. Environmental change, I don't just mean, although it is a big part of it, climate change, we understand a lot better as a result of satellites and space observation. But also things like, degraded environments in forests and so on, for example, agricultural change. Astronomy. Definitely. Astronomers have benefited enormously from being able to put observatories in space. We were having a conversation before the lecture started about the James Webb Space Telescope. So placing it, all right, it's a long way beyond low Earth orbit, but it's right out there. It's above the Earth's atmosphere. We get a much better view of the universe as a result. So, we've benefited hugely. But more famously, until the launch of James Webb, the Hubble Space Telescope at bottom left there was a classic example of that. And also nefarious things, espionage, yes, quite clearly. Although interestingly, spy satellites are now so good and our own publicly available data is so good that we can get access to images through Google Earth that were comparable to what spy satellites did in the 1980s. There's a famous example of a Russian shipyard in what was then Leningrad, or is it up in Murmansk? Anyway, it's a picture of a shipyard, but you can see that on Google Earth now because the publicly available data is so good. And at the time, it was hailed as a real step forward. And then navigation too. If any of you drove here using a sat nav, well, there you have it. Your satellite navigation system helps you arrive in places. We walk around cities with phones tapping into that. We're very, very used to that. In fact, one might argue that now we no longer know how to read maps very well. I mean, I do because I grew up before these things were ubiquitous. But the point is that it's become really, really helpful to us. So I don't know anybody really in the astronomical community who suggests that we shouldn't have satellites. We're very well aware of their benefits. However, it's a little bit more history. I like this example, by the way, because it connects to the Royal Astronomical Society. And it also because I had a fantastic lecture by a US historian on at a conference I was at only virtually a couple of weeks ago. As early as 1961, there were thoughts early on about the militarization of space. In fact, you might argue that the deployment of Sputnik drove forward the US nuclear missile program, for example, because of fear they were falling behind the Soviet Union. It wasn't quite true, but it was something that was a political driver. One of the examples was this thing, Project West Forward in 1961, proposed to put 480 million dipole antennae, little copper needles in space. Now, they're tiny, okay, but the idea was to create an artificial ionosphere. So the ionosphere is a layer of ionized material in the Earth's atmosphere. If you can use it to send radio signals around the Earth from the ground. And the idea was to make that more resilient, and they wanted to be able to use it to do global communications. So this was being put up there. It was very soon after the development of the first telescopes for radio astronomy. Now, again, forgive me if you know this already, but radio telescopes, they're basically antennae on Earth that detect radio waves from space, just as we use optical telescopes to detect visible light. So the fear was that this would interfere with that, because these things would be in a belt around the Earth and thereby interfere with more remote signals. And there were protests, genuine protests from astronomers in the UK, also in the Soviet Union, and protests in the US as well. What I hadn't appreciated until I went to this conference a couple of weeks ago was that there were popular press protests too about this sullying of the near-Earth environment. Very interesting. And although it was modified, some of these things were launched and some of them are still there. Now, they're not doing enormous harm. There aren't a very large number of them there. But it was recognized. And you can see, I don't know if I can get the point. That's the, right, I was told this is not the pointer. This is the thing that switches off the, I won't use that. I'll just gesticulate. On the right, you can see a reference from our journal, our then journal, Quarterly Journal of the Royal Astronomical Society. It doesn't exist in quite that form anymore, from June 1962. And it reports that the Council of the RAS took a position on this, views with greatest concern the reported intention of NASA to put these dipoles in space, and it would begin to shut off radio astronomy, and it could be a permanent effect. So serious organizations are doing this, as well as the kind of, doubtless the Cold War propaganda from the Soviet Union at the same time. And so right back that far away, in time, more than 62 years ago now, this was already being described as a concern. And then I've been trying to find the reference to this. Francis Graham Smith, who was Astronomer Royal at the time, referred to it in 1980 and just noted, this is long after this West Forward project, noted that the number of satellites was increasing and that you could see them in the sky. And perhaps if they increased greatly, it would become an issue as well, that we might have a sky full of satellites. I should say, by the way, around the same time as this, as well as the Americans doing this, the Americans were the only people to also do nuclear weapons tests in space before they were banned. And one of those actually destroyed the first UK satellite because it created a big flux of particles and damaged it, which is an interesting piece of history there. I guess we kind of got over it. It also did a lot of damage to, well, it did things like set off garage doors and alarms and so on across the Pacific. So there was a big effect from it, actually, surprisingly large. But those are supposed to be banned now as a result of a treaty, which I'll come to later on as it happens. So what are we talking about with all of this? It's important to distinguish, when you describe these things, where these objects are. So the biggest concern now are the satellites in so-called low Earth orbit, and that's everything up to 2,000 kilometers above the Earth. So relatively close, actually. If you think about 2,000 kilometers, the Earth is about 12,000 kilometers in diameter, so it's not that high. And most of them actually are a few hundred kilometers up. So really, really quite close in terms of physical distance. It's closer than Scotland is from here. And it's really well populated. I would say, by the way, you won't be able to read all the text on this slide. I just want to demonstrate the different zones. So the green one there is the low Earth orbit. And then you have unimaginatively named medium Earth orbit, which covers everything out to quite a long way. Halfway in that zone there is the GPS system. They go around the Earth twice a day. And then higher up, the geosynchronous ones. And these are satellites that go around the Earth every 24 hours, essentially, so they're always above the same place. And that was an important concept in communication, because they're always in the same part of the sky. You could use them to send a beam up and then send it round to somewhere else on Earth that could see it. And with a few of those, you could transmit signals around the Earth. So it was an important concept. It was described. I don't know if it was the first person to do it, but the science fiction author Arthur C. Clarke described that concept, I think, in the 1940s, so well before they were launched. And then beyond that, high Earth orbit, that tends to be where you have more experimental scientific things going on. So that's the kind of thing we're describing. And the region of most concern is the lowest one. So it's not the first time, what I'm going to describe to you, it's not the first time that we've had concerns about this region of space, but for a different reason, although that particular concern is getting worse now. And it relates to this sort of rather clunky 1980s looking graphic here. This is supposed to be, it's from NASA, but it's supposed to be a schematic showing you the effect of space debris. So you may well have heard of that too. When you put things in space, it's not always a clean process. Okay, you launch rockets up there, you get bits coming off them and so on, and they stay in orbit. You also get dead satellites on the largest scales, and you even get things like astronauts dropping tools when they've worked on the space station. And most of this stuff then goes into orbit and floats around the Earth. Now, that might not sound like a big deal, but the problem actually is that there's an awful lot of it. And I think in the lecture you come to next month, you'll hear more about this. And these things are moving very quickly as well. So if you're on the space station and even something the size of a bolt hits the space station at, say, I don't know, 7, 10 kilometers a second, that's not good news. It will do a lot of damage, much faster than a bullet. So there's been a lot of interest in this already, and up to 2019, which is a crucial date for reasons I'll come to, you saw a lot of discussion about this, trying to manage this, worrying about how long this would be in place, because without human action, a lot of these things could be up there for hundreds of years, and worrying about collisions and how that got worse. However, in 2019, we saw the change that has now come to dominate thinking in astronomy, which is we saw the launch of the first Starlink vehicles. Now, SpaceX is the company that owns Starlink and its network, and SpaceX is part of Elon Musk's business empire. So there's a lot of money behind this, one of the richest men in the world driving this. And in 2019, he launched the first few tens of satellites. And then I think perhaps later than we should have done, at that point, we realized that this was the beginning of something big. Now, had we been looking at the right documentation in the US and the Federal Communications Commission and keeping an eye on all the licenses, we might have seen this coming. The reason we didn't, I think, is because astronomers just weren't really used to doing that. Our radio astronomy colleagues did it a bit. We were not, most of us were not really aware of what was going on. So to give you a sense of the change, there were 2,000 active satellites in low Earth orbit in 2019, and already we have an additional 5,000. So those 2,000 have been launched to a lesser or greater extent, because some of them come down, sometimes they burn up in the Earth's atmosphere, over the course of the first 6 decades of the space age. That many satellites have been launched. And now we have an additional 5,000 just in the last 4 years. So it's become much more populous. Now, look, you can talk about Douglas Adams and so on and say space is very, very big. Well, indeed it is. However, it also can get crowded when it's the space near the Earth. And so that's one of the reasons we should be concerned about this is the effect on the existing material and instruments and satellites that are already up there. However, we're moving to a very different domain. So it may just be, and it's very hard to, this is quite speculative, but some of this is grounded, and I'll explain why. You could see 400,000, 500,000, a million satellites by the end of the decade if all the filings and all the proposed plans come to fruition. Now, it probably won't quite be like that, because apparently there is a sort of land grabbing effect whereby satellite operators say, I'd like to put in a license for many more satellites than I plan. And part of that is done to prevent rivals from grabbing the same orbits and the same space and so on. However, there's no doubt that we will see at least many tens of thousands, because those are the things that are being built now, and those companies will want to launch them to get a return on their investment. So at some level, this will change in this way. And that represents a very significant change. And when you look at the amount of stuff that's already there, you can see that graph shows how it's changed over the last, well, pretty much the whole of the space age. The left bit there is 1957, so up to 2022. You can see the blue line there is the active satellites. So it's suddenly taken a ramp up. As a result, you're obviously seeing a steady increase in the number of ones that are defunct, because satellites go wrong and they end up with dead objects there. And then the resulting debris ramps up as well. That's because there are sometimes, well, there are collisions, and there are also sometimes deliberate weapons tests, which are pretty irresponsible, but you're allowed to do it if it's your own country's satellite. So if China decided to destroy a US satellite, that would be a major international incident, very dangerous. If they destroy their own, then they are, it may be frowned upon. If they do it in such a way that it claims it doesn't damage anything else, then they can get away with it. So, tell you about some of the systems. I'm not going to talk through everything they do, but they're broadly all communication systems that we're seeing being launched. And the first and most famous one then is Starlink, as I mentioned, run by SpaceX. And this is a constellation for delivering home internet access. So anybody, I'm not going to encourage you, but I don't blame you if you do, anybody who lives in, say, a remote area particularly can buy a Starlink terminal and connect to one of these satellites. Now, it will give you reasonable internet access, actually. It's not too bad. It's quite expensive, apparently. I think it's a few $100s just to get the base station for your garden, and you have to set it up in a particular way that it doesn't get obscured by nearby trees and all those kind of things. But there is no doubt that a lot of people are using it. I think there are around 1 million users globally now. That's not anything like the number, obviously, that access the internet through other means, but it's a market and it's growing. I think Musk's target is 100 million. So the first phase of these, 3,000 satellites, pretty much up there. And then the next phase, another 30,000 satellites already. And the first 2,000 of those or so are up there. I believe that's right. I was checking the figures this afternoon on one of the reference pages. And you don't see that many pictures of what they look like, but SpaceX provide PR photos like the one above there, just of the solar panel unfurled, and then down below there is the system they launched to launch many tens at one go. So they put a vehicle up and they launch tens. It might even be they do hundreds of the next generation ones. So that's very familiar. It's ubiquitous. It's definitely working, and it's available to consumers. There's also OneWeb. We took a particular interest in this. I can tell the politics of this are fascinating, and you can dive into that at your leisure. I'll tell you a bit of it. This one provides internet access as well, but it doesn't generally provide it to home consumers. It's doing it through third-party companies that redistribute it. 650 satellites, they are now all in orbit, and this is part owned by the UK government. The story behind this is that they started up, and then the company went into receivership. And then during the height of the pandemic, this was in early 2020. So then during the height of the pandemic in the first wave, the slightly notorious figure, if you've been watching TV over the last few days, Dominic Cummings made a decision which was unusual, it's fair to say, bypassed some of the normal processes to get the government to buy, it should say £400 million, but they're $500 million. I keep meaning to correct that. But anyway, we own a chunk of this system and procured it, and there were various parliamentary inquiries and investigations into that, and it still, I think, remains something that was a bit unorthodox. Part of the thinking at the time was that it would provide an alternative to the Galileo system that the European Union has, and we lost access to that after Brexit, so we haven't quite regained it, and I don't think we can under the terms of the withdrawal agreement. So for that reason, it was bought for that reason. It probably isn't going to deliver that, actually. The second generation of satellites might, but these ones won't. These are notable for being a bit higher up as well, and that's a problem for reasons I'll mention later on. And then there are more recent players. This one, AST, they originally had some connection with the UK. They don't appear to anymore. I was talking to the guy, Martin Marsden, who runs Space Park Leicester, who had originally brought them into a meeting with us, and now they're not well connected to us, at least, although they might be talking to some of the other bodies. And this is the idea of you have a direct satellite connection to your mobile. And to do that, they're using systems which are about the size of tennis courts. Now, as I'll mention later on, big satellite reflects more light. So something the size of a tennis court is really big. And the proposal is to have at least, I think it's possibly about 100 of these. So smaller number, but they're very big in the sky, or very bright in the sky, at least. And the observations of those certainly back that up. And there are people out there who go out to look for when they're passing over, and they do see them. They're all put up by rockets. And in some cases, they will do things like unfold and unfurl when they're in space. So I'll take all these questions at the end. So a more recent player as well, Amazon have something called Project Kuiper. And this isn't, I assume this isn't about dropping, no, I'm being flippant. It's not about dropping things on your doorstep like drones. That's not really very technically feasible. But this is also an internet system as well with another 3,000 satellites. So on the same scale as the first SpaceX ones, but not on the second scale. And they have now launched their first two. That picture was the best I could get. They're just, they were going to use some more innovative new rockets. They weren't confident about them. They're now using rockets that are left in stock that actually have Russian engines in them. So presumably they'll run out fairly soon, but that's how they've been deploying their first ones. And it isn't just private companies. There are not just the UK ownership of one, also the European Union has a proposal too. Now, I will say later on, they're not, none of these companies, well, not all of these companies anyway, particularly nefarious in that sense, but the EU has a proposal for a €7 billion constellation, and this is supposed to be, again, about tackling internet dead zones in remote parts of Europe as well as in sub-Saharan Africa. And they are doing their feasibility studies, and the tender documents were being put together and so on. So this is under development. It could be built via the European Space Agency, which the UK is still a member of, presumably by big European companies too. And, it would just be there because Europe wants to a sort of multipolar world here where they want to have European power in space along the lines of the Americans. So why do we worry about this? Well, optical astronomy depends on observing the universe with telescopes. Now, obviously, telescopes more than 400 years old now. And, we think of it classically as bringing light into your eye. That's still pretty much how they work, except that instead of your eye, you've now got detectors that take it and process it, turn it into an electronic signal, and then we process all those beautiful images that we see in the public domain, in the popular press, and so on. And they observe the universe in, visible light, and then a little bit into the near infrared, so just beyond the red end of the spectrum, and into the ultraviolet, a little bit as well, but that's more in space. They are typically located in sites like the one above there. That's the European Southern Observatory in Chile, fantastic facility. The room actually used to work for these guys. Really easily, I would say, or still up there with the world's best sites. Absolutely amazing place. And you can see that's called the Very Large Telescope, that facility there. A totally different topic of conversation is about trying to get different names for telescopes into the public domain rather than just very large, and the successor, the European Extremely Large Telescope. However, joking aside, they're wonderful instruments. There are also counterparts in places like Hawaii and La Palma in the Canary Islands and Tenerife in the Canary Islands as well, and even some in the Antarctic and places that are a long way from light pollution, but also very high up as well. And the reason for that is to be above the distorting effects of the lower Earth atmosphere. And space-based observatories, most famously in the past, the Hubble Space Telescope, and more recently, the James Webb Space Telescope, they complement these. So if you really want to get away from the effect of the Earth's atmosphere, you put your telescope in space. And so why are we worried about satellites of these? Well, I assume, how many people in the room have seen the International Space Station at one time or another? Few hands going up. If you never have, it's really easy because it's quite bright. If you look on websites like Heavens Above, or even if you have an app on your phone like Stellarium, I think includes it as well, you can look up when it's going to be overhead. And it's fairly frequent. Every few weeks or so, you will see it either in the morning or evening sky. And when it goes overhead, it's really bright. It's brighter than any star, and it's really obvious. And the way it shines is that it shines by reflecting sunlight. And that's how all satellites do it. I mean, if they had little lights on board, believe me, you're not going to see those from 350 kilometers away. But you do see the light that reflects off them because they often have quite reflective surfaces. And so satellites, all satellites will shine or be visible to the ground, the eye, through that system. And so in some cases, and this was at the outset, when you have a lot of these together, as you did with the first SpaceX launches, or you do with all SpaceX launches, particularly in the first designs, they were all clustered together. And so people reported seeing these, what were called strings of pearls, shortly after launch. And people went out and looked at them. I don't doubt they were exciting to see. I've only ever seen a slightly rubbish one. It was a bit fainter, but it was still interesting to see this sort of one satellite after another going across the sky. And so even fairly early on, people pointed telescopes at, say, more distant objects. And this is one here which has certainly some galaxies in it, because I can tell from the shape, as well as possibly one or two stars, and thought what would happen as these went across. And of course, what happened was that you had all these streaks going across, because if you have a time exposure and you have a bright source moving, it moves across and it leaves a line. So that's what it does to your image. Now, that was a sort of specialized thing early in 2019 where there weren't that many of them. Now it's much more ubiquitous. And although they're spread out, many people, if you take an image, even amateur astronomers will say, oh, there's a couple of streaks on it which have resulted from this. And this is very early days. It's worse in some other cases. This requires explanation. This again was taken in 2019. And it's an all-sky camera attempting to image meteors. So what you do there, or a wide field camera anyway, what you do is you point it at a large area of the sky, and meteors, if you've ever seen them, they're very fleeting. So one thing you can do is go and count them and sit there and write them down and so on. Or you can use one of these systems, and then over the night, it will record where they are and you get an idea of the rate and so on. The problem is that when you have bright satellites, and obviously also things like aircraft, which you see a bit here as well with those dots, they go across the camera as well. And it's a camera that's monitoring for a long period of time. So, you build up a lot of streaks on it. Now, there are ways around this, which I can mention later on as well. But the point is that these wide field things are badly affected. And in that image, it says detected meteors 110. I think everything moving brightly across there, whether they're going left to right or right to left, those are almost certainly satellites in the Starlink constellation. There may be some others as well that just were unrelated that are going through. And if you look, there are some short streaks that are undoubtedly meteors that are shooting stars, because they're bits of debris coming into the Earth's atmosphere and they're only very visible for a very short time. And on the right there, as I mentioned, that those dots, I think, are probably the flashing light of a plane going over. But the point is that for the science, attempting to understand these things is problematic, okay, if there are lots and lots of bright things. And it turned out as well that even one telescope in space, namely one of the most famous telescopes of all, the Hubble Space Telescope, is affected as well, because it's below the satellites, but it's a lot closer. It's a factor of, say, 4 times closer to the satellites than they are on Earth. And so they have these very bright streaks on their images too. And I think the estimate at the moment, when the time this work was published by some brilliant interns who were working at the European Space Agency, last 2 years ago they published it, they realized that about 15% of the data was quite badly compromised. Now, if you get a thin streak, you can probably deal with it digitally. If you get something like that on the right, that has basically left a big hole in your image. So for the science of astronomy, that's not great. So to sum it all up, really, as I mentioned, these things shine through reflected sunlight. As it happens, if you're in this part of the world in the summer, they're generally not visible in the middle of the night if you're near the equator, because they're in shadow. So once the satellite moves into shadow, you no longer see it. It moves into eclipse, it's described. But at this part of the world in the summer, the sun is never very far below the horizon, and that means you see them all night. Now, that's just a thing. They also add to kind of background light pollution. So the more and more and more of them you have, we think that's adding about 10% already, and maybe that will ramp up as the number goes up. And I think for me, in terms of human heritage as well as astronomy, if you imagine all these things deployed, that number there, when I wrote this, 10% of the visible stars in the sky, if you're in a dark site, could be moving satellites. It could be more like a third. That may not sound that bad, but I would put it to you that if you go to one of those very dark places and you see that star field, do you want to be looking at this crawling mass of objects or not? Because that's what you might be talking about. So, there are, I think, aspects of this which says it shouldn't just be, in my view, for large private companies to make the decisions on this, but we should all have some stake in it. To give you an idea of the kind of effect, well, that is a classic example on the right there, and this was really even before these deployments, where there was a brightening in the image, and people assumed it was a distant galaxy, and it turned out to be an old rocket. They looked at it and they thought, oh, we've discovered this amazingly powerful thing at the edge of the universe. No, it was actually an old rocket reflecting sunlight. But the prediction is some of the best telescopes might have as much as, say, 2/5 of their frames affected, maybe more as this goes on. So that kind of science that we're doing becomes compromised. And as I mentioned, it affects orbital things, but it also has an effect on the kind of things we look for. So say if we're looking for near-Earth objects, potentially hazardous asteroids, it adds a degree of confusion to that. And the bold thing is what I want you to remember from this, if nothing else, this affects everywhere on Earth. because these constellations are designed to communicate with the whole world. So by definition, there will be nowhere that you don't see them, because if you didn't see them, then they wouldn't be doing their job. And then I'll mention as well radio astronomy, which is crucial for this too. This is a classic example of a telescope there. Has anybody ever been up to Jodrell Bank in Cheshire? Yeah, a few nods. Yeah, it's a fantastic site, World Heritage Site, absolutely delightful. It's part of a network called eMerlin, a big dish that collects radio waves, brings them to a focus, and then turns them to a signal, and we analyze the universe that way as well. And they tend to be located in remote places or protected sites. The one underneath is the Square Kilometre Array Observatory, which is under construction in Australia, which is fantastic, a global project to build a huge and very sensitive radio telescope scattered across the outback in a very remote region and also in southern Africa. And these are amazingly sensitive. So they have to be in very, very protected places and places that are a long way from signals. So Cheshire is not actually as ideal as it once was for that, obviously, but it is still working well. And already, even before these things were deployed, the new ones, the line of communication satellites, those geostationary ones that go around the Earth every 24 hours, they were already quite visible. So you see that band there, that's the interference in those. That was detected by a telescope on Tenerife, Radio 1 Quixote. And on the right, then, a simulation showing the kind of bands and interference that might emerge once these new systems switch on. And already seeing some of that, but it's not, it's not totally deployed yet. We're waiting. Well, we don't want to wait till the end of the decade. We want to tackle it now. So what you have to understand with this is these signals are billions or even trillions of times more powerful than things we want to detect at the edge of the universe. So I shouldn't say the edge of the universe, in the distant or early universe. So we look for signals that are from really distant objects, so really faint, and you need good sensitive telescopes to do that. If you have a stonking great internet transmitter, imagine moving this, say, your home router in front of a very sensitive radio telescope. That's de facto what you're doing, sending this signal down to it, completely destroying its ability to function. In theory, at the highest level, it could damage it. It's not very likely, but the problem is they're so sensitive and they're not well protected. So some of the radio spectrum is covered by something called the International Telecommunications Union, but that was designed, those rules were drawn up in the early 60s, and now radio astronomers want to observe all the radio spectrum. And they've negotiated that because they've put the telescopes in remote places. So we can have our mobile phones, we can have our radio taxi companies and so on. All of that is possible because we negotiate the use of the spectrum and we put them in remote sites. But again, the issue is that it affects the whole of the Earth. Now, the other thing I should mention here is if you're interested in things like even, maybe very, very speculative, but even detecting signals from other civilizations or tracing the early universe, this is why this science matters, to answer some of those big questions. And there's also an issue of the electronics on satellites are not as well regulated. So there's a lot of passive radio interference, and there was a paper on that actually out earlier this year. But the bold text is what matters here. It doesn't do you any good to move to a remote place if you've got something that's designed to transmit a signal over the whole Earth. So I will mention a couple of other aspects of this that concern us, or they're slightly outside of our remit. So one is the environmental impact. If you launch hundreds and hundreds and hundreds of launches, does that start to have a significant carbon footprint? What about all the stuff coming back into the atmosphere? We've not really worried about it before. But if you have hundreds and hundreds of satellites entering the atmosphere, burning up, as to some extent we want them to get them out of the way if there's debris, what does that do to the upper atmosphere of the Earth? One of the papers by Aaron Bolly, who's really working hard in this area, notes it means, I think, about a 7-fold increase in the amount of aluminium coming in, for example. Will that have a big effect? We don't actually really know yet. Probably not massive, but, it's something we should be thinking about. And so there are also then people arguing you shouldn't be doing this anyway. You shouldn't be burning up very expensive resources because, you should be thinking about a circular space economy, not just throwing away and discarding all that stuff. So, and then the cultural impact as well. This is, there's the Starlight Declaration. There are UN treaties and so on that don't quite recognize the night sky as they should. But there are certainly indigenous people who see access to it as a core part of their culture. And of course, it's a global one, actually. If you think about literature and art in the West as well, it's important there too. So again, it's this conflict with that principle. You know, do we say that the only stakeholders in this are private companies, or do we argue that all of humanity has a say in this as well? And I would argue we do. So, you know, the dark sky places that we're creating across the globe, this Starlight Declaration that covers it all, you know, how does that fit into this? So how are we protecting this so far? Well, a few more slides. We regulate a bit. I mentioned that there's the International Telecommunications Union. There's lots of complexity, and this is the easiest answer, actually. But in the UK, we've got Ofcom and HQ on the Thames there. They report into the International Telecommunications Union. They're all supposed to regulate the radio spectrum and also, to some extent, cover deployment of satellites as well. So when someone wants to launch something, they have to go to Ofcom to get that agreed. And there is some protection in the radio spectrum, but there isn't any protection in the optical spectrum. Not yet. So astronomers reacted to this in our own clunky way 4 years ago by creating working groups. It's the kind of thing we were quite good at doing. And then we realized a few weeks ago, we were having some of the same conversations that we've been having 4 years ago, which is understandable, but would be good to make more progress. And then there's the International Astronomical Union, as well as my own body, the American Astronomical Society, the European Astronomical Society, and many others, all trying to work on this problem and bring, say, satellite operators into the room too, because in some cases they're doing the right thing. It's just that we would like them to be compelled to do the right thing. And so you can dig up various reports on this as well that set out all the recommendations we want. We're also doing things like looking at the legal framework. Did you know there was an outer space treaty? Most people probably didn't. I'll go forward to that. 1967, there was a treaty signed to prevent military activity in space, partly on the basis that there had been nuclear explosions in space. And so we want this to remain in place. And in theory, some of the provisions of that cover this stuff. So Article 6, says that states authorize activities. So if it's a UK company putting satellites in space, states like the UK are responsible for that. And also you can request consultation on activities believed to be harmful. So there is a lot of work going on at the UN now to try to understand that and what we might do to influence it. And that's done through this wonderful committee called the UN Committee on the Peaceful Uses of Outer Space, which again, you've probably never heard of, part of the United Nations Office for Outer Space Affairs. And they're based in Vienna, in case you're wondering. But imagine, that'd be a great job title. And so various countries have tried now to bring this into the agenda too. I am pleased to say the UK has been okay on this, not perfect, but okay. And they did listen to us and they went bold and said, you need to think about protecting the night sky in your international conversations. It's not getting easy agreement, primarily because the war in Ukraine and the tensions between Russia and the West and so on and China are not making it easy to reach agreement. We set up the astronomical community, and I take a minor part of credit for this. We set up a center last year to look at this as well. So there are now internationally astronomers talking about this very routinely and trying to develop different aspects. They're doing things like trying to track the satellite. They're divided into hubs, tracks where the satellites are, work with industry. Community engagement in this context means talking to things like indigenous peoples. I think it should be wider than that. I think it should be talking to everybody, and they're sort of taking that on board. And then the policy hub one, where we're trying to say, what can we do with governments, which is an area I'm working closely in. And then, so I'll end with some cause for optimism, by the way. So there are actually, we're starting to see some movement by states on this, okay, more than I was expecting. So there is this Effelsberg agreement. This was signed between Starlink and the Bundesnetzagentur in Germany. So it's the regulatory body that regulates telecommunications there. They have a great radio observatory at a place called Effelsberg, as it says. It's a big steerable radio telescope, so like the one at Jodrell Bank in Cheshire. And they said to Starlink that you can only access our markets and our consumers if you agree to protect this site. And that's what they've done. So now the Starlink beams are not allowed to illuminate that observatory. And that means, I guess, that if you live very close to it, you don't get access. But my view would be we should absolutely have something like this in the UK and indeed around the world. Protect those sites. You know, what harm does it possibly do? So, you know, this has been very positive, and it'll be interesting to see how that plays out. I don't know how many Starlink customers there are in Germany. And then another thing by the way, has anybody heard of the Astra Carta? No, you know, the reason I'm asking is because there was a press release and some fanfare around it, which appeared to have almost no impact. The only thing I saw was a picture of King Charles meeting Brian May from Queen, with no context other than they were at a meeting about this. However, I'll mention this because it was a pleasant surprise, as is the next thing I'll come to. In July, an organization called the Sustainable Markets Initiative, which I admit I hadn't heard of until this is connected with Charles III, launched this Astra Carta idea. And you can see the logo there, and I'll leave you to pick holes in some of the way in which it's designed. But the point is that the motto around the edge is about protecting and caring for the infinite wonders of the universe. So there is this great underpinning principle there, which a lot of companies, probably because it meant a trip to Buckingham Palace, if I'm being cynical, but that's probably a little unfair, but signed up to it, you know, and said that, yes, they will endeavor as organizations in the space sector to agree to this. And then they've got a document which is obviously designed in the style of the Magna Carta and also the Terra Carta that Charles had done a few years ago. And I think more relevant to us in the astronomical community is this. This is the Earth Space Sustainability Initiative. And this is a UK project that was launched on the same day, probably with even less publicity, if I'm honest. Even fewer people noticed it. But we were one of the signatories of this memorandum of principles. And you know, you can look this up yourself, se.org. It lists who signed it and what they are. And that includes sustainability in general, but also very much about protecting the sky. So we have signed up to something. This is funded by the UK Space Agency until about the end of the year. They want to go much beyond that, and it depends on how their work pans out in the meantime. So I suppose you could help them if you wanted to by emailing them and asking them questions, so it demonstrates that it's actually working. But we are talking to them about the details of this. But we were pleasantly surprised to see that this document, and indeed some others that we've seen recently, includes protection of the sky in it. You know, there's no particular reason it had to do so. So what are we doing next? Well, I mean, look, my main concern about this is that I think that we end up stumbling into this somehow, that we're talking very positively, actually, and I haven't included that because there's lots of details I wouldn't really have the time to go into, but we're talking really positively to companies like SpaceX about the design of their system. They've done things like they tried darkening them, it didn't work very well. They tried this visor to reduce the reflectivity, and they've now introduced what's called a dielectric coating to scatter the light so that it doesn't appear as bright. So, you know, for a company that was under no obligation to do that, whatever I might feel about, say, their ultimate boss, Elon Musk, and so on, this is actually a really positive step. However, that's been done on essentially a voluntary basis. There is nothing in US law or international law at the moment for them, as a US company, let alone in UK law or European law, that actually compels them to do that. So these are all things that companies do if they feel like it. And my worry would be that there comes a point where they say, well, we can't actually improve our standards because it hit our profit margin too much, so we're just not going to. Or that worse, say another country, you know, Russia, China, and so on, say, well, actually, we don't care. You know, this doesn't bother us that much. You worry about the sky. We all live in cities. We can't see these things anyway. So does it matter anymore? So that's my concern about the way this goes. On a more positive note, I would say that actually getting any kind of traction on this stuff with government, let alone the wider public, is a good start. You know, that actually with the fact we've got slightly fanciful headlines there, like detecting alien life is going to be higher, which is harder, which is true, but the fact that it's there is a positive, the fact that people are a bit more aware of it. And I think, you know, I genuinely think that actually, if we're going to think about that aspect of human heritage, that we need to protect this and ask those questions and just say to policymakers, MPs and so on, that we are bothered about this, just as we're bothered about protecting the sky from light pollution, if that's, you know, if you share that concern. So our work is to carry on doing those things with the International Astronomical Union, the big overarching body that we're affiliated to, talk to this new SE group, go to these international meetings, try to make that political case as well. You know, it's been much more fruitful than I expected in some ways, the conversations we've had with ministers and MPs and so on. Talk to the press and public, so talks like this are part of that. Talk to the media, we definitely do fairly regularly about it. And also, I guess the final italicized thing there, are we talking about, say, space environmentalism too? You know, do we need to think about protecting the near space environment in the same way that we do the environment of the Earth? Now, it's different. It's not an organic place in that sense. There is not life there. But it does have at least some bearing on life on Earth, whether that's through the advantages of things like satellites or through the disadvantages. You know, do we really think it's a good idea to fill the upper atmosphere with all the space debris, or let alone to leave it up there? So these are the questions, I think, that become more resonant and more relevant now than they have been in the past, just because we're seeing this big change. So if you wanted to help with this, and nobody has to, by the way, but there's never any obligation, but it's nice to have a collective responsibility. If you want to, you could write to your MP and ask what they think about this. You know, I've encouraged our fellows, obviously, to do that. But if you totally reasonable to write and say, are you interested in this? Lots of MPs have put up parliamentary questions about it, which we're quite encouraged by. If you're an amateur astronomer, I should take the last bullet point off. That's an oversight. But if you're an amateur astronomer, you can actually observe these things if you want to, even with a pair of binoculars, and report them with that link there. So it's quite easy to do. And you can go out and you can say, how many of them, how bright are they? Is this a problem that's getting worse or not? And people, that data would be really, really valuable, because it's quite difficult to collect, actually, because professional observatories are expensive and they can't just be left to gather this kind of data so easily. So, you know, people going out and doing it in their own time is really helpful. And the final thing was a survey, which actually I saw the results of, which unsurprisingly, the FAS is the Federation of Astronomical Societies in the UK, and unsurprisingly, people agreed it was an issue there. So really, I hope this has brought to your attention something you might not have known about before, that there is this big shift. Okay, we have a paradigm shift in our use of space, you know, and that it does have ramifications for our view of the sky above our heads. And I think that matters. And I also, you know, as well as the associated environmental issues, which concern me greatly as well, but even just as an astronomer or just a human being, I want to be able to look up at a reasonably unfettered night sky. And I think everybody should have the right to do that. So I'll happily take any questions on this. And, you know, I hope I've been provocative and able to make you think about this too. But thank you very much.
Okay, we'll start off with questions in the room, and then I'll go to the chat channel. And I'll hand out the roving mic. Can you hold it up and speak into it like this, please, so that the people on Zoom can hear you properly?
Good evening. Thank you for that lecture. It was really interesting. I wanted to ask, if you were in a position to directly influence or even dictate international policy on this, you know, what would it look like? How many satellites do we actually need? Yeah. And what should the life cycle of them be? How would you regulate it, considering all the international bodies and the geopolitics involved?
Well, I think the thing we really want to get, I think, is a new outer space treaty, but that's really hard. And the risk is that in negotiating it, people start to ignore the existing one. And I don't want a world where, you know, testing nuclear weapons in space is seen as an acceptable idea again. However, were that possible in a utopian world, we definitely need that global regulation at some point. Because even if you don't care about the sky, you need to manage it so you can continue to operate all these systems that we've become so critically dependent on, or at least that make life easier for us and have such advantages. So I would say, look, it's going to have to be in place internationally, where we don't just do, I mean, the current system is essentially a bit of a Wild West. You can put stuff up there, agree it with your national body. There aren't really limits on the numbers. You allocate certain orbital shells and so on. There are ways you have to behave responsibility around the radio spectrum. But beyond that, you could put up really bright things and there wouldn't be a problem. Now, in US law, for example, space advertising is banned, I think that's right, because there were proposals to do that. That hasn't stopped other companies around the world from suggesting it every so often. And, you know, worse than the sort of stuff I've been proposing, I guess, would be to see the sort of golden arches floating across the sky, you know, as imagine. So we need to reach a point where that just becomes a routine part of it, that astronomy, for example, is recognized as space activity. That's one of the things people have been talking about, and that it's routinely included in those considerations. We're trying to get to that point in the EU and in the UK and in the US. You know, there's serious work going on to try and get to that point. As you can imagine, what happens instead is that the companies would say, well, we'd rather have guidelines, we don't want regulation, as they always say, inevitably. And our argument is, no, I'm sorry, you need compulsory legislation to bring and regulation to make that happen. And yeah, I mean, there are also then arguments about, well, there are all the other stuff I was mentioning. I mean, should it be a natural thing to just carry on ever increasing population of satellites, what about sharing uses? Do we really need multiple operators operating the same systems in the same space? Or could they be sharing that infrastructure? What do we think about the waste of resources associated with burning all this stuff up again, even if we have to do that to manage space debris? So those sort of questions ought to be in there, I think. We haven't really had to think about it before, because when you had hundreds of satellites, even, let alone tens, it wasn't seen as a big problem. But now I think we've reached the point where, well, it is. And I worry about that continued use of it and managing it. And it needs to be on the radar for people who care about that aspect of the space environment and what it means for us on Earth. But it needs that international regulation. It needs good national stuff that flows from it too. And it just has to be something, an obligation. If you want to launch a constellation of satellites, you need to be mindful of that.
Is that feasible?
Well, that's the politics, right? I mean, I think at the moment, a new global treaty is far from feasible. And I think it got worse after the war in Ukraine. There's no way Russia is going to be a responsible actor on this stuff at the moment. They just don't care, basically. But in the future, let's be optimistic and see what happens. Certainly, there are good things going on at national and regional levels. So, for example, the UK is okay on this. I'll give them the benefit of the doubt. They've got a consultation open at the moment. We'll see what they come back with. They said they funded with a little bit of money, maybe, but they funded this Earth Space Sustainability Institute. What it means in other parts of the world, hard to say. The US will probably be okay. The European Union will be okay. I guess the Western democracies that are most likely to have space programs will be all right. I don't know what the Chinese will say. They have a big astronomy program, so in theory, they've got a vested interest too. But we'll see.
Can I ask about the effect on professional astronomy particularly? Because for the ordinary person looking at that sky, for the amateurs who are observing visually rather than taking images, actually these satellites are quite faint. And I've been watching that sky since before you were born. And you see more than now, but it isn't that obvious to the ordinary casual observer. And likewise, somebody going to a dark space. But with professional ground-based observing, you have a battle between this particular very important, very popular science and the huge human benefit of spreading internet in all these different places, particularly Africa. It just seems to me, if you look at the balance of sort of influence on those two things, you have a very important, very inspiring science against economic development for billions of people. So is there a way that technically the professional astronomy can actually cope with rather more of these effects than they have been till now?
To a certain extent, yes, is the answer. It depends on your field and what you're doing. So some telescopes are much more badly affected than others. If you've got a wide field telescope, it's quite problematic because it's going to be full of these things. If you have hundreds visible at any moment, that's a big issue. If you have something which is looking at a very narrow field of view, then, you might get one street running through, less of a problem. In terms of your wider point about economic development, well, I think one of the things I would say about it is that at the moment, we shouldn't see this as some sort of charitable project by SpaceX. It's not. It's there to make money. There aren't many users in sub-Saharan Africa at the moment because it's too expensive. If you look at the monthly income of even people in middle-income countries, Ghana, say, they cannot afford to spend $500, $600 on a Starlink terminal and then spend a couple of $100 a month on receiving that. So it's still very much a Western user base. And, so I would question, so yes, it offers that potential to reach remote areas, but also, build up the fiber infrastructure on the ground too. And yes, okay, but none of that means that I say it should somehow be switched off or shouldn't be there at all. I just think the designs need to be part of that regulatory process, that you should say not only about the number of satellites that we're discussing, but also the fact they can be designed to be less reflective. They can meet those standards which are already devised. So there are already submissions put into the UN about how bright they should be and so on, and how we want the radio beams to be constrained. Do that, do it well. And then, I wouldn't say there will always be compromises, but it will help a lot. And it doesn't make sense either, for states to spend across the world at least billions on a science like this that we've done for decades, because, well, actually decades, centuries, because we regard it as so inspiring, and then not to be able to get the return on that, and actually to make it more expensive as a result. But in some cases, it is fair to say, yes, it's possible to live with it by stacking and so on. There are particular techniques you can use to minimize the effect, but it is more expensive as a result nonetheless, however you do it. You have to spend time developing software, changing the way you do things, accepting a loss of data and so on, which in some cases can be really serious.
Just to follow on from that, in terms of the economics, if the reality of why this is possible is because the price of getting stuff up there is now so much cheaper than it was 20, 30 years ago, an optical telescope, professional optical telescope, my understanding is the logic of doing that is that it would cost you billions to make, you know, if your university wanted a Hubble telescope 20 years ago, it's never going to happen. But now things are so much cheaper. You've got universities in the UK coming out with CubeSats and things like that. Does that mitigate it? Not an ostrich approach, but like go beyond and telescopes go into space.
Yeah, it's still really expensive to put telescopes in space. I mean, if you look at JWST, that's still what, $10 billion. So if you wanted to put up many Hubbles, it would still be a really expensive undertaking. And it's also, it's much harder to use them. I mean, you've got to, well, it's much maintaining them, servicing them, so on. You're having to do all of that essentially remotely. Okay, so you can put astronauts in space to do it every so often, but it's a non-trivial exercise, something on the ground. You can go along and you can adjust it and all of those things. And it's still vastly cheaper than putting anything in space. We're a long way from, say, moving all optical astronomy off Earth like that. I mean, you occasionally hear people saying things, I personally think it's nonsense, but I've heard things like, you know, oh, let's move all the manufacturing off Earth because it will move all the pollution associated with this process into space. It's just crazy. You know, you manufacture these products in space, bring them back down to Earth and all the rest of it. This is the sort of thing you're talking about. And I don't think it's a runner given the size of the field and the rest of it. And I doubt it ever will be actually on that scale. I think we'll definitely put more telescopes in space as time passes, but each one requires a long process of decision making. They're still at least hundreds of millions. So they're many times typically more expensive than comparable facilities on Earth. But I know Elon Musk says he'll do it. I just don't think it isn't going to happen like that.
Thank you for the talk. I was just wondering if any modeling had been done about any sort of catastrophic events within these orbital shells that you refer to, that are bands within which they deploy these satellites, given that there are so many. Has that been modeled at all, or?
Yeah, space debris is what you're referring to here. So if you have an ever more populated shell, you have to do complicated traffic management. And I'm not at all entirely up to speed with this, but there's a good speaker on this is Hugh Lewis in Southampton, who's an absolutely recognized expert on it. And he will refer to the number of conjunctions that take place, which is basically a close pass between bits of debris and satellites. And that's really shot up, as you can imagine. The figure is tens of thousands last year. And so that has to be managed. And then, of course, the risk, you're right, is that if you get a few collisions, it's slightly mischaracterized sometimes, but there's this description of something called the Kessler syndrome, where you get a cascade effect and a cloud of debris leads to more destruction. And so, yes, that has been modeled, and it does worry people because you don't want to destroy a lot of the infrastructure that we're so used to depend. Well, as I keep using the word depending on. We don't absolutely depend on it. We would go back to the sort of 1960s in terms of what we were accessing, but I don't think most people really want to take that step back.
Right. I'm looking at questions on the chat channel. There's some questions which are a bit off piste, I think, about some. Well, I'll read them out. You'll see. So, I wonder if there may be space colonization and how we would protect ourselves from this. And I'm also concerned about importing diseases from outer space organisms. I don't think this has got anything to do with the subject tonight, but
yeah, I mean, that's not my main concern. I mean, no, I mean, once you get into the vacuum of space, it's such an extraordinarily harsh environment. I mean, there are people do things like, I'm trying to remember the description of this. There was one, it's a bit anecdotal. There was a case of the Apollo 12 lander landed next to Surveyor 3 on the moon, and they went along and scraped some stuff off the camera and took it back to Earth. And then the idea was that I think it was Streptococcus bacteria survived there for 3 years. But then there's also controversy, I think, about whether it was contaminated in the lab on Earth as well. No, it's such a harsh environment. You don't really have to worry about that stuff coming down to Earth from space. Chances are, if it ended up there, it had come from the Earth to begin with.
Right. Next question is, how effective has the Chinese space sail been at clearing up debris? I hadn't heard about this, but
I'm not sure I'm familiar with that, but there have been various attempts to grab debris. But I think the thing is to realize, and I know you've got another talk on this, is that these are grabbing single objects. And if you're talking about hundreds of thousands of small pieces, it's not even scratching the surface. It's a tiny step forward. It's an important one. But yeah, it's a very small start.
Well, can I recommend the questioner here to, I don't know their name, but come to the next talk.
Absolutely, I was going to say exactly.
That's going to be on space
find that out
debris.
there. I would say too, though, that it's yeah, I mean, this is also a legal issue, actually, as I understand it, which is that if you put the debris in space, you're responsible for cleaning it up, and no one else is allowed to without seeking your permission, because you still own the debris and the object. So I did wonder what happens if two things collide and then there's a big mix. How you distinguish at what level do you have to distinguish between them? But yeah, it's problematic, and also that then comes back to the influence on the sky and so on, because the question of ownership means that they're supposed to be the ones responsible for it and consulting with them and so on. A lot of the provisions in that treaty have never really been tested properly. They just stopped they didn't stop militarization of space, because it is by definition quite militarized with spy satellites and so on, but they stopped military activity mostly in space.
Right. And the last question from the moment from the chat channel is, what would a circular space economy look like?
Well, that's a really good question. And actually, it's come up, for me, it's come up properly in the last couple of years as an idea. And I think it's a good one. It says, if you have particularly rare resources used in certain electronic systems and so on, that you shouldn't just simply burn them up in the Earth's atmosphere when they're lost. If you burn something up in the atmosphere, that's it. It's beyond recovery. So the idea is and it is not trivial. The idea is somehow, I suppose, about repurposing existing things in space and so on, and working on that. That will not be easy. However, I do think if we get to the point of an ever increasing mass of this stuff, we'll have to start thinking about it. Is it really a good idea to take incredibly expensive systems and just destroy them and on a huge scale? So I think the answer to the question is it's being worked on. And it is one of the questions in the current consultation on sustainability in space being run by the UK, which we will respond to. Probably just this one in passing, saying we support the premise, but it really needs to be worked out.
Right.
Oh, what a question. But a very very cheap way of improving some of the visibility. Couldn't all these satellites and rockets be painted black rather than white?
Yep, they could be painted black rather than. Now, interestingly, when SpaceX became aware of this, and that was fairly quick, and they worked particularly with our counterparts in the US, and I ended up talking to them because I tweeted something rude about whether Elon Musk cared or not. And so their public affairs person came to London, not just to see me, but I think she was seeing rather important people in the UK government, but she talked to me about that. And one of the first things they did was design something called DarkSat. But the problem was that predictably, if you paint things black, then they heat up more. So that was an issue. So they did that first of all. And then they did this visor thing, which was where you put something in place to block sunlight from reaching the most reflective bit of the satellite. And the difficulty with that is that the satellites talk to each other optically using lasers and so on. So that prevented that from happening. So now the latest thing is a sort of variation of the dark side thing. Is dielectric coating. What it means is that in this case, it's scattering the light so that instead of it coming down as a single beam down to Earth, it's spread out and diffused. Yeah. So, but yes, in theory, the interesting thing was that was tried, and then they had to stop it. They were getting too hot. So.
Talking about the effect on ground-based astronomy, I suppose mostly professional, but also amateur to some extent. Some of the new techniques in astrophysics now are based on large-scale surveys for time variations in objects. There are some very large telescopes being constructed now, which will survey the sky very regularly every few days and look for changes of various sorts. It seems to me that this kind of task now is much more difficult with these satellites, creating enormous confusion in the huge numbers of images they're taking. So I suspect those are the people who are very worried about this.
No, you're absolutely right. But that's exactly, and one of the slides I mentioned in passing, I couldn't talk about that data, but the Vera Rubin Observatory is a great example of that. It's one that will survey the whole sky every 3 nights, and its whole premise is to look for changing things. So that can be stars varying in brightness. It can be these big explosions in distant galaxies, the optical counterpart to so-called gamma ray bursts. It can be looking for near-Earth objects moving across the sky, all of those things, and they depend on quick changes, relatively quick changes. So if you have the confusion of hundreds of moving satellites, it makes it much harder. So yeah, it does. And they are really struggling, and they are absolutely among the people most concerned. Interestingly, some of the telescopes I showed you pictures of, they're less worried because they look at a very small part of the sky. So on any given image, it's much less of an issue. But yeah, there are certain facilities and certain areas of real cutting edge research that will be really hard.
Right. Well, that looks like the end of the questions then. So it's time to reflect on what we've just been listening to. And it's really very interesting because it's clear things can go either way. And I'm at least reassured with there's some optimism with, for example, with Starlink being able to turn their radio beam off when they pass over a radio astronomy observatory. I mean, that shows there's some response from SpaceX on the Starlink satellite system. So let's thank Robert Massey for giving us such an interesting talk.